So the easiest way to do these is to highlight what they're talking about, right? Either take your pencil or just in your head. So they're talking about RV and ST are those. And it's kind of like we just got to pick, well, any one of these lines could be our transversal. But then we just look at 11. Well, it's not inside, right? It's not between the lines, so it can't be anything interior. And the only thing we have left is corresponding. So we look at corresponding. Yeah, it's angle 8, and it would be B corresponding angles. So it'd be angle 8, B corresponding angles. All right, the next one says if angle 3, let's erase this really quick. If angle 3 plus RVT equals 180, so let's highlight those. Angle 3 is here. RVT is, let's do that in maybe light blue. Light bleu. Okay, so I can see which lines should be parallel, right? Just by coloring those in. Those should be our parallel lines. Because RVT is this big one, 9 plus 10. Then what segments must be parallel? Well, I colored it in, didn't I? Yeah.
Would it be WT and RS?
Sure.
Or could you do like VT and RS?
Yep. You could do any one of those. Anything from up here, pick 2 letters from up here. I'll just pick WV. And I'll say it's parallel to, well, there's only 2 letters down here, so I'll call it RS. Yes, Evan?
I put VR and ST. Is that because it ends like right on the line and it doesn't go through, you know what I mean?
Well, did I even highlight this line at all?
No. But if it's...
Let's really quickly highlight the angles that we're talking about.
Yeah.
Maybe that. So we said angle 3, right?
Mm-hmm.
And then we said angle RVT.
Mm-hmm.
Do either one of those angles even touch this line?
No.
The angles have to create the transversal and the parallel lines.
Okay. But can't we say that because, well, it says that if angle 3 plus angle VRT equals 180,
Mm-hmm.
so...
They must be same side interior for that to work.
Oh, I looked at 2 and 3. Like angle 2 and 3 added together, it would be 90. And then 5 and 6 would be 90.
Well, does it say that
No.
anywhere in there that it would equal 90? No. So you went on that assumption thing. I'm telling you, the easiest way to do these is just take a colored pencil and lightly color them in and maybe erase it. All right, I have tons of colored pencils. Just whatever angle they're talking about, color that one in. Color in the other angle, and you'll see that I didn't shade in this one at all, so that one has nothing to do with it. I think that's the easiest way, or even with your pencil, just lightly shade in. Yeah.
Does it matter if you go WT or WV?
Nope, any one of these 2 letters. You could have said TW too, or TV. TV would have been fun. All right, and then it would have been same side interior. And I would have known it was same side interior immediately because it says they equal 180. That's the only ones that equal 180. Alternate interior angles are always congruent. Corresponding angles are also congruent. So you should have, as soon as you saw 180, been able to go same side interior. It's got to be. All right, any questions on those? No. If you're lacking on these, make sure you go back to the homeworks and you practice them. All right, practice them over and over and over. Sabrina.
I got for my answer that VT is parallel to RS.
Mm-hmm. That's correct.
Oh, but the answer on there said WV to RS.
Uh-huh, but if you were listening, I said any one of these 2. You just pick any 2.
Oh.
I actually went through all the possible combinations. Any 2 will be the whole segment. All right, for those of us that did that chapter kind of checkpoint thing that I said you could do last night if you wanted to, did anyone have questions on it? I didn't make it homework, so probably no one did it. All right, hey, those are good, especially if you didn't get these right. Those would be good to go back to and practice on. We do have a test next Thursday, all right, because we keep covering new stuff. That's what those checkpoints are for. I don't collect them for homework, but you should do them so you can kind of see where you're at. And Robin came up with a great point. Do I have to do all of them? No. Just pick out ones that you think would be good practice. Like, I know how to do that, I know how to do that. Ooh, I get those wrong consistently. Let's practice on that. All right. We're going to go into triangles today. We're going to go into triangles today, and it's kind of just going to be like a fact-finding day where I just give you a whole bunch of facts. We've all seen triangles before. Nothing brand new. We'll give you some brand new information about triangles, but we've all seen triangles before, and basically it's just three segments joining three non-collinear points. Because if all three of those points were collinear, it would just be a straight line. One of them has to be up in the air to make your triangle. So let's go ahead and draw a picture of a triangle. So if I have three non-collinear points, 1, 2, 3, and I connected them all, boom, boom, boom. Well, not quite boom. There we go. And prior to this, we might have just seen that and been done with the triangle. But in geometry, we need to have naming things. So we need to have letters attached to all this stuff. So we'll call it A, B, C. And the way we can name this is we can just call it triangle A, B, C. And we'll see that again. So that's its name. Triangle A, B, C. This is the symbol. Rather than having to write triangle over and over and over, we just draw a little tiny triangle to stand for it. Now some important facts about this triangle when I'm describing stuff. Every one of these points is a vertex. So a vertex is the point, or it's the angle formed by the point. So a triangle has three vertices. So that's a vertex, and B is a vertex. We call the lines that make up the triangle sides. So a triangle has three sides. Mind-blowing stuff here. We have a side, we've got a side, we've got a side. Yes?
So what definition did you give vertex? Just like the angle?
The angle. Yep. So a vertex would be angle C. So I guess we could put that in. This would be angle C. Would be that vertex. And this would be angle B. And the side would be, let's give an example of one of the sides. This side would actually be the segment A, B. All right, so a vertex is an angle. A side is a segment. All right, don't give me the entire line because the entire line does not make up that triangle. If you said it was line BC, I might not take off points. I might. But just know that if I name the whole line, we'd have all this crap that we're not actually using, and we're saying that's part of our triangle. That doesn't make sense. All right, but that's a triangle. We've seen them before. Might be just getting used to saying these vertex. Like, what's a vertex? What's a side? All right, triangle ABC. Like I said, we can just draw it like this. Triangle ABC is shown below. So the vertices of angle ABC, like I said, are angles. So it'd be angle A, angle B, and angle C. Vertices is the plural of vertex. They're not vertexes. They're vertices. All right, sides. For our sides, we are going to have AB. We are going to have BC. And we are going to have AC. And you could have did those in any other order. Now here's where myself and the book differ, all right, in my definition of what's a vertex. My definition of a vertex is it is an angle. In the book, it is just going to call it points. All right. So I came up with these angles are my vertices. Well, the book answer, and what the book's going to want you to put a lot of times, the book answer is going to actually be the points. A, B, whoop, and C. So if you're answering these, and it has what are my vertices and what are my angles, if you look up your actual answers, it might differ in the book. And this is why. Because we differ on our opinion of what a vertex is. I just want to bring that up in case you put these down, and the book just has points listed. All right? Then you'll be like, oh, I'm fine. I'm fine. All right? Yes?
Like, for a test question?
I would accept either one. Yep, I would accept either one on a test. So if you want to be straight by the book so you can check your answers 100%, just go ahead and put your points down. All right? Or put both possibilities. It's kind of up to you what you want to do. And what kind of sets this apart is because in the book it might say, what are your vertices? And then what are your angles? And you'd be like, well, I have the same answer down. All right? So these would actually be our 3 angles as well. But per the book, you want to check your answers and stuff, they're going to have the points down. Okay? Are we okay with that? So if we're checking our answers, it might be just a little bit different. Honestly, all I'm looking for is, do you know that the vertex is here? And the vertex is here. And the vertex is here, and you're not naming an entire side. All right. Classifications. Classifications of triangles. We can either do it by sides, or we can do it by which angles are given to us. So we have ones that are no sides are congruent, at least 2 sides are congruent, and all sides are congruent. So the first one we're going to cover is, what if I don't have a single side that is congruent? That is going to be called a scalene triangle. This is a scalene triangle. If I have at least 2 sides congruent, it is going to be isosceles. And finally, if every single side is congruent, does anyone know this one? Seemed like last year, yeah. Equilateral. But here's where it gets dicey. Is an equilateral triangle isosceles? Is an equilateral triangle isosceles? What do you think, Amber?
No, because all the sides are congruent.
Okay, maybe. That's one guess. Evan?
Yeah, because it says at least 2 sides are congruent for isosceles, and you could have 3.
Does that change your answer at all?
Wouldn't they just be called the same thing, though?
They could have the same name. Because just like Evan pointed out, it says at least. Right? Does it say exactly 2? So, an isosceles triangle can just have 2, or it can have all 3.
But we'll only give you 2, right? So won't we just classify them?
Yes. So this is isosceles because it's at least 2. This one's not equilateral, but an equilateral triangle will always be isosceles. All right, because at least 2 of them are, because in fact all 3 of them are. So an equilateral triangle is also isosceles. Yes?
If we were naming that, would we put the equilateral and
We'd put equilateral. We're going to pick the strongest name, right? The more specific to it. But there are questions that are like, can an isosceles triangle be equilateral? And it might go backwards. Does an equilateral triangle have to be isosceles? Or does an isosceles triangle have to be equilateral? So we got to think about that an isosceles triangle can be equilateral, but an equilateral triangle does not have to be isosceles. Or an isosceles triangle does not have to be equilateral. But it can be. It's that at least.
Can I go to the bathroom really quick?
Yeah. It's the at least part that messes everything up, and that's why I underlined it. Maybe I'll circle it again. Cool. All right, classification by angles. Oh man, we were creative as mathematicians on this one. Whew, this is gonna blow your mind. All right, if my triangle is made out of just acute angles, it is an acute triangle. Who wants to take a guess what it's called if it's an obtuse? If there's one obtuse angle, yeah.
Obtuse.
Obtuse triangle. Whew. Who wants to take a guess if it has one right angle? Sabrina.
Would it be like a right angle?
A right. It's actually just called, you're on the right path. It's called a right triangle. Just a right triangle. The only weird one is if they're all congruent. It's kind of like if we have equilateral, this is going to be equiangular. Equiangular. And I didn't have room in there, so I just threw it down here. So it's going to be equiangular. I'm going to tell you right now, we don't use that much. We don't use it that much because we're going to learn later on that an equiangular triangle is in fact equilateral, and equilateral is easier to say, so most of the time we just say it's an equilateral triangle. We will use it in a section. I'm just saying for future reference, we generally refer to things as equilateral, not equiangular, just because it's a... Say it. Everyone just say it real quick. It doesn't really flow off the tongue, does it? I mean, equilateral, I guess, isn't the best, but it's still better than equiangular. Yeah. Equilateral. Easier to say. Just know what this means, but when you get further on, generally you stop using it as much. All right, don't worry too much about this for like a test. But there might be questions on homeworks and stuff that might need this. Sometimes for a drawing, in order for me to prove something, I have to add a line to the drawing. I have to add a line to the drawing, and that is okay. You can add things to the drawing as long as you don't, change this to be 180 degrees. You can add things to the drawing to help you solve it. So that's called an auxiliary line. It's a line, ray, or segment added to a diagram to help in a proof. In this one, we need it. So Theorem 311 says the sum of the measures of a triangle is 180. You need to know that fact. All right, you need to know that fact. I don't care if you say it's Theorem 311 that says it's 180, or just say a triangle equals 180 degrees. At some point, it should just be ingrained in you that a triangle equals 180 degrees. All right, we're going to go ahead and prove that. So it says, given that I have triangle ABC, show that angle 1 plus angle 2 plus angle 3 equals 180 degrees. So this is the auxiliary line I'm going to draw. I'm going to draw a straight line across here. And I'm going to call it L. And then I'm going to go ahead and label these angles as 4 and 5. Well, I drew this to be parallel with this. All right? I drew this to be parallel with this. My given is a drawing, so we're not actually going to start with the given. We're going to start with, hey, I drew this line, and specifically, how did I draw this line? So my very first step is going to be L is parallel to AB. Now, per the book, Sabrina?
I was gonna say that I was gonna say alternate interior, but then I realized when I thought it was so I found out it should actually be, I think, corollary 1.
It will be corollary 1. It can't be alternate interior because we don't even have parallel lines. So we're going to, as soon as we don't have parallel lines, it's not. So we're going to use corollary 1, because corollary 1 of 311 says that if I know two angles are the same in both triangles, Well, I know E and R are the same, and I know that 1 and 2 are the same, so that means the third ones must also be the same. So that's just going to be corollary 1. Our remote interior. Remote interior. What a remote interior and an exterior angle are. Exterior angle is any angle that we draw. So you can draw an exterior angle. And an exterior angle is going to equal 180 when you add it to the angle across from it. So once you draw an exterior angle, the two angles not involved in the exterior angle are going to be our remote interior angles. All right, the ones opposite the exterior angles are going to be your remote interior angles. So real quick, don't draw it on it, I just want you to see. If I would pick this as my exterior angle, then my remote interiors would be over here. They're on the opposite sides. Now, there's something really important about remote interior angles and exterior angles. I want you to note something, and it's going to lead to our next theorem. Note that 25 plus 40 equals 65 degrees. Same thing over here. If I know my exterior angle and I know my remote angles, 70 plus 30 equals 100 degrees. So if I know my exterior angle, I know what these should equal. If I know what these two equal, I know what the exterior angle equals. So our remote interior angles added together always equal the exterior angle opposite it, right? Because your exterior angle is always going to be opposite. All right, and that leads us to our next theorem. We're not going to prove this one. It was just if we had time, it'd be awesome. But we're not going to prove it. We're just going to say the measure of an exterior angle of a trigonally. Anyone know what a trigonally is? Let's just say triangle. I think we know what it meant. That should be triangle. I gotta fix that. Triangle. I don't know what a trigonally is, but we'll say it's a triangle. Equals the sum of the measure of the two remote interior angles. Important stuff, because can you kind of picture a question they might say in the book? It might say, you know, 1 remote interior angle equals 24, the exterior angle equals 40. What is your other remote interior? All right, stuff like that. And that's one of our examples. In triangle ABC, measure of angle A equals 120. And an exterior angle C is 5 times as large as angle B. So angle B is x. So that'd make my exterior 5 times x, because this is 5 times as large. And the way we'd set this up and solve it is we would just say, well, 120 plus x must equal 5x. All right, and if we went ahead and solved this, we'd find out that x equals 30 degrees, which is in fact my angle B. Yeah.
Are we going to do like the proof in theory 3-12?
Are we going to do that right now? No, no. I just put that on there if I had time. You can feel free to do that. It's in the book too. It's in the book too. All right, example 2. This one's more interesting. I just wanted to make sure I got to that. So the proof would be fun. It's not a hard proof, but I wanted to get to this last problem for the homework so you guys can see how this works. One angle of a triangle is twice as large as the smallest angle. The other angle is 6 times the measure of the smallest angle. Find the 3 angles. All right, so they're talking in terms of the smallest angle. So I'm going to have S. I'm going to have S here, and I'm going to call that's my smallest angle. One angle of the triangle is twice as large as the smallest angle. So I'm going to call my smallest angle, hang on real quick. That's my smallest angle. I'm just going to call this angle 1. Angle 1's my smallest one. Angle 2 is going to be twice as large as the smallest angle, so that's 2 times S. And that third angle, the other angle, is 6 times the measure of the smallest angle. So angle 3 is going to be 6 times S. What happens when I do angle 1 plus angle 2 plus angle 3? What should they equal? Anna? 180. So that's all we have to do. To solve this, we just have to, really quick over here, I'm going to put a little line because this is where I'm actually doing my work. I'm going to say S plus 2S plus 6x equals 180. So that's 9s equals 180. And so we're going to have s is just going to equal 20 degrees. So that means one angle is going to be 20 degrees. This angle is 2 times s, so that's 40 degrees. And our final one is going to be 120 degrees. And real quick, I'd go 120 plus 40 plus 20. That's 60 plus 120 is 180. We're good. It's always good to do that little check, especially if you're on a test. All right, so we have 5 minutes right now. What I want you to do is go ahead and start the homework. I'm going to check that homework that was due yesterday. Okay, so just have that on your desk. It's in your notes, so you don't have to worry about flipping through your notebook.